The recording has started, so I better start working, hey?
Okay.
All right, so I'll just flick that across the chat so I can. All right, so we're going to jump a few chapters in this space because it is the virtual machine space. So chapters 5 and 6 is going to run now because they kind of overlap with what we're going to do on Thursday, which is the start of the CCNA course. So rather than delaying them till later, and then you'll look at it going, why are we doing this again? Get them out of the way early. That way you're absorbing the information around the same time for the two subjects. And the three main operating system virtual machine type chapters are 9, 10, and 11. So we'll jump to them, and then we'll come back to 7 and 8 afterwards. Okay, so we're going to do it a little bit out of sequence, but it's to do so that this actual chapter space within the course is actually to do with virtual machines. So we'll jump to those chapters and do those as it's within this actual timing within the actual course, and then come back and do the others. So that's the plan for the next few weeks. And within the timetable, we also have another week after that. So if we need to spend some time setting up and getting people ready, we can. Now, I will next week put out the link to my OneDrive that has a ISO for Windows 10 sitting in it, so I'll share that link. So if anybody needs it, they can download it. Again, don't be overly concerned if you can't, like if your internet doesn't allow you to download it, that sort of thing. Don't worry about it. This will be part of the let's just spend some time catching up on practical exercises when we get back into the classroom. All right, so there'll be the labs and going over it when we get back into the classroom. So not a biggie for those that need to spend the time doing it. So as I said, this one, yes, it's getting, I'm a little torn, Stuart. It'll be good to get back into the classroom, but I'm not looking forward to the 2-hour drive to start off my morning.
Yeah, no, I feel your pain. Well, I don't feel your pain, but I understand your pain.
Yeah, so it's a bit of a hike from Melbourne up to Bendigo every morning. So, all right. So, as I said, chapters 5 and 6 are basically basic networking chapters. So these work well with Thursday when we kick off our chapters in CCNA curriculum. So I got to remember to add you all into that Netacad course. So we'll be looking at the types of components in a network, how they're drawn as far as standards, icons and stuff like that as well. We'll have a quick look at what protocols and standards and services are. No, but there's an article out in the news saying it looks like schools may be open before their end of term 2, but there's nothing official through the pipelines yet, Robert. Our initial briefing from college management was don't expect us to get back before term 3. So as they're starting to ease back restrictions, we'll wait and see what that looks like moving forward. My crystal ball is not the best. Yeah. So all right, so we'll look at the devices on networks, very basic security and functionality around networking. There is a whole chapter on securing devices, which is, I think, chapter 12 or chapter 13. So that looks at it a bit more in depth. We'll have a look at the different types of network cables and connectors. So let's get into the first section. So these are the standard icons that Cisco uses within most of their courses. So on the left-hand side, we've got the main intermediate devices, which are basically the devices that handle your traffic as it's going from A to B. So if you're using a wireless device, you will come up through a wireless access point, whether that be a standalone access point in a network, in an enterprise, or like you have at home, a wireless router that you connect to. The same with wired connections. You normally come up via a switch and then exit your network via the router. Now, your home device has those two items in the one device. So your home router is both a router and a switch. It's not, generally speaking, your standard domestic router has a 4-port switch inbuilt into the router. Okay, so modems tend not to be seen in this day and age, but they're basically the old dial-up in the dim dark ages, which you regional folks are probably still using. I know my dad was still on dial-up until about 2 years ago. So we're from the other end of the state. We're up around Sale, so in Gippsland. So the property was still, yeah. There's definitely no NBN out there. So then you have the actual host devices, which are the users of the network. And yeah, the squeaking of the network modem, yes. Once you hear that, you'll never forget it. So your desktops, your tablets, your smartphones, your servers, printers, scanners. So any device that connects to the network to use the services on the network are host devices. And the various media that connects all these devices together are our straight black, which is our patch cables, our LAN copper cables, and the lightning bolt symbols are WAN connections, which are generally slower connections. You got the sine wave for wireless signals, and then your cloud to represent anything basically not in your control. Oh, okay. Bye. And by the way, could you change your name so I know who you are?
Bye, guest.
Having guests logged in doesn't help me record your attendance. Okay. All right. So the different types of network topologies and descriptions thereof. your PAN, personal area network. This is basically your wireless headphones and that you use with your phones and that. So Bluetooth, use this. So basically 1 to 2 meters is generally acceptable with Bluetooth. Modern Bluetooth devices do allow for a slightly longer length, but generally speaking, if you want decent reception over a wireless connection of any distance, you use the bottom option, which is Wi-Fi. So local area networks are the ones that we will basically concentrate on in CCNA, and in the classroom we'll basically be doing the local area networks as well, which is where we basically use a switch and routers to connect everything together. Virtual LANs are basically segregation of traffic via software in the switching fabric. So that's, we will do multiple labs in VLANs in the second part of CCNA, the second module. It's all about switching. So we'll cover that in more detail later on next semester. But just think of it as software separated traffic, because that's all what it is. It's not hardware separated. Wireless mesh, we'll look at the horrid ZB and that in a little while. I've had discussions with some guys that have the pleasure of working with that mess. They're not impressed with it. So metropolitan area network is basically providing Ethernet speeds over the metro area. It's a hybrid cross between a LAN and a WAN. And a WAN is a wide area network that spans a very large, so going around the world is considered a WAN. So metropolitan is outside of the campus, but within the same metro area and giving you the same high-speed connections as a traditional LAN connection. Now, that being said, our WAN connections are slowly increasing in speed as more people go to fibers across the country. The last one on this side, virtual private networks, VPNs. I'm sure you've all heard these before. Do we have a third? No,
I don't say bless you on the third.
My wife always seems to sneeze. Morning, Brock. Brock. Yeah, get the pronunciation right. Brock. B-Rock. Get it right.
I just
we'll certainly discuss them. Proxies are just basically a intermediate device that you can apply policies to. So they're there to apply corporate restrictions on the enterprise traffic.
Like schools have proxies, and if you can find another proxy, you can play games on it.
Yeah.
Yeah.
People these days understand how to bypass proxies, so we have come up with applying policies in different elements of the network to limit that. Firewalls are so much better for applying policies now rather than proxies, but we'll get into that. Proxies are still useful out in the net if you want to hide a little bit of where you're coming from. You can pop through a third-party proxy. Unfortunately, proxies are well known within services like cable TV services and that. They whitelist proxy servers. So, alright, dial up. That ugly telephone 56K was about it. Telephone line can take, in theory, 64K of bandwidth, but remember the modems have to actually talk to each other and keep the link up. So most of the time that was done out of band, so the 56K speed was recommended so that you had bandwidth to keep the link open. ISDN, integrated services on a digital network. You bundled telephone lines together in this service. You got basic and primary services, which basically basic service, you had 2 telephone lines and which were known as bearers, and a D, which was a separate connection just to keep the administration of the links working. So they were known as out of band management. And broadband is, well, what we laughingly call broadband here in Australia is something slightly better than a telephone line. So within our systems, DSL was still very much a way of life in Australia until a couple of years ago. So this is using our normal phone line, which can carry our voice and data, but they separate themselves on different frequencies. So you have a filter on your handset for your telephone, so you didn't hear the high frequency of the data connection on your handset while trying to make a phone call. If you didn't have that filter on, it was not a usable phone, basically. Cable is basically the same sort of thing, but dedicated cable networks came along in Australia for TV. They weren't in America. They actually had cable networks in valleys where normal connections couldn't get in. So they'd have a big antenna station on top of a hill, and then the cable would circulate the channels into the towns in the valleys, and that's where cable TV networks originated in the US. Fiber, well, in theory, it gives us greater bandwidth and allows very fast connections. The way it's rolled out here in Australia is not so much. Well, the way we will talk about fiber, you have a send and receive fiber.
Yep.
Okay. The way fiber is rolled out to the houses in Australia, you get one fiber.
Right. So
you can transmit or you can receive.
You can't do both.
So that's called half duplex, which means just because of their cost-cutting methods, you've lost half your speed straight away.
Yeah.
Okay. So, yeah,
So is that just from the house to the node, or is that everywhere?
that's the last mile, what they call the last mile. So that's from the house out to the multiplexer on the street. Yeah.
Okay. So in theory, you could get an in and an out if you wanted to.
I'm sure they will give you an in and out if you request it and pay for it.
Yeah, of course.
Yeah, exactly, James. You just got to pay through the nose for it. The connections in Australia is, I won't, I will tell you, it's depressing. My mate that migrated to America just occasionally puts up a speed test just to rub our noses in it. And, you know, we're going, oh, we've got so fast, we've got 25 megabits a second. And he goes, yeah, I'm having a bad internet day. And he posts up a speed test and it shows 500 megabits per second. And he's paying less than what we are. When he first moved into his house, he peaked at 900 megs per second.
God.
So more people have moved into the neighbourhood since then, so his speed's dropped off.
Still though, that's
Yes,
really fast.
we don't. Australia governs our speed rather than giving everybody, which is just the pricing model that the major ISPs have forced onto Australian customers. Yeah,
Well,
I
it's
won't get
mainly
into the politics of that one.
Telstra
Hey?
and Optus at this point, isn't it? Because they kind of own everything. Oh, and
Yeah.
Vodafone, I suppose.
No, Telstra and Optus are the two major ISPs for Australia.
Yeah.
Basically, everybody else buys IP addressing off those two. So
Yeah.
they're the ones that basically control the pipes that go offshore.
I see.
It used to be Telstra.
Which I thought,
Yeah.
but then they've
So
obviously.
basically, Telstra owned the sea cables that went off through via Perth and I think it's Sydney that heads over to New Zealand. But there was a third connection put up through Northern Territory up north. That one was Optus and another group of people that owned that. So that's where we saw a slight lessening in the cost of internet. All right, site wireless. Wireless is a wave. So if you have things between the source and the destination of that wave, you get a distortion of the wave. So this is why for radio signals and satellite dishes and things like that, we need a clear path. For example, if I know one company I worked at, if it was a really, really windy day, the tree would blow into the line of sight for the satellite link and the branches would break up the signal. It would be enough of a distortion to break up the signal and have bad internet connections until they decided to resolve the issue with a chainsaw.
As you do.
Yeah, so it's gone. All right, so satellite is pretty much the same thing. It's an RF, but the intermediate station is a satellite in orbit up above. and it uses a dish to concentrate the signal to punch it over that large distance up to the satellite and back. There is very large delays in satellite communications because of the fact that you are punching up into the atmosphere and back down. Well, it's not a standard recommended item for the toolkit, Christopher, but yes, if it's one to be aware of if you're dealing with satellite dishes and things like that. Yeah. Mobile telephones, I'm not going to preach to you about how they work. You all use it on a daily basis. So cell phones and mobile phones, Americans call them cell phones because of the way mobiles use a honeycomb effect to actually plan out their transmit and receive zones. So they're like a cell in a honeycomb. So they adopted the cell mentality. So Wi-Fi can be shared across your mobile. So you can have wireless devices connecting to your mobile phone as a hotspot, and it will use the mobile data to get to the internet. The cell phone also enables you to have Bluetooth, wireless, USB cables hanging off of them. They're a very versatile mobile device. So the next phase of this little presentation will be about how TCP/IP works. Now, TCP/IP is the model that is used to represent how the communications occur within a network. Now, there's two models we use in teaching. One's called the OSI model, which has 7 layers, and the other one is the TCP/IP model, which is the model that represents the actual protocols that are the most common protocols used across the network. So the application layer represents all the software that uses services on the network. Transport layer represents the layer that sets up a session or a communication. They're the TCP and UDP are the ones that control the flow of the conversation. Internet is where our internet protocol, IP, runs, which actually transports our data from point A to point B. And network layer is where we actually connect to the physical world outside of the computer. So this is where we cross over from our software in our PC or phone or whatever, so our operating system, into the network card and out onto the physical medium that transports the electrons. So the two protocols that you saw on the last one, TCP and UDP, are the ones that control the conversation. TCP is the big brother of the two. So this one has numbering and tracking of the data. So when an application sends a comms out, it's known as data. When it comes to the transport layer, it is divided into segments so that they can be little discrete segments of data that can allow for the sharing of resources between thousands of devices using the network. So each segment is individually numbered and can be tracked using TCP. The other end is consulted with before sending any information to it. In other words, a handshake occurs saying, "Hi, I want to send you some information. Yep, I can receive information now. Go ahead. Okay, here it comes." That's basically a three-way handshake. So the recipient acknowledges the receipt of those segments. By the acknowledgement sequence and system, the source knows whether or not it needs to transmit any data that is not received by the other end. On the other side of the coin, you have UDP, which is the little bratty brother. It really doesn't care whether it gets to the other end or not. It's just like snail mail. You just throw it in the letterbox and who cares? Wipes their hands of it. I've done my bit. I put it on the cable. Next. Okay, that's best effort delivery. It doesn't check with the destination to make sure it gets there. It just sends the information on its way. Now, because there's no error detection or correction within UDP, it is a lot faster because it has less checks and balances to go through with every segment. It does actually sequence track, so it does number each segment, but it doesn't worry about holding it all in a buffer at the other end until it gets it all. Okay, so we use UDP for voice conversations because we don't want to hold up the traffic and resend part of a word 2 words later. Okay, so if you're sending bulk data like an email or something like that, if you hold it in the buffers until you get all your segments, it's not going to make any difference to the recipient. But with a voice conversation, if you hold the conversation until you get all the pieces, people aren't going to like that. So UDP is the preferred protocol for that live interaction type traffic. You will be expected over the course of the networking side to learn and understand the well-known key port numbers. A port number represents an application basically. So the port 80 HTTP, so web traffic, and port 443 is our encrypted, so our secure web traffic is on that well-known port. Every time you type in a web address, you send out a probe for a domain name resolution, which is on port 53. I was going to say 43 for a second there. Port 53, that converts the name that you type in the web browser to an IP address. And list goes on with emails, 25, so POT, IMAP, TCP 22, 23 for Telnet, SSH. These are the 2 protocols that we will mainly use when setting up and configuring devices in our network. So you will become more familiar with these as we go through. So FTP, port 20 and 21, one's actually the control port and the other one's the data transfer port. So if you really want to upset somebody, you allow the control port through and then block the data port. It really screws with people's heads. Yeah.
I'll keep that one in mind.
So I'll let you read and learn those ones off by heart or by yourself.
Thank you.
Okay. IEEE standards are basically an international electronics Institute of Engineers or something. I can't remember what it all stands for off the top of my head today. But basically, IEEE is, just think of it as a large international standard body regarding communications. There's about 5 major ones that deal with IT protocols around the world. So 802.11 is Wi-Fi. A, B, G, N, A, C, and all the others that are now coming out that are even faster will have a 11 something. So as you can see there, we have 2 main frequencies, 2.4 and 5 gigahertz. It's basically been agreed around the world to keep these 2 frequency spectrums available to anybody to use. So you don't need a license to transmit on these 2 frequencies. They're narrow and quite restricted in what you can do with them, but any device and anybody can transmit on those frequencies. That's why Wi-Fi uses them. The trade-off: the higher the frequency, the lower the distance that can be transported. Traveled. Higher the frequency, the more bandwidth that you can transport. That's what I was leading on to. Okay, that's bad. Generally 5 is supposed to be the more stable, but yeah, it is more susceptible to interference than 2.4. But yeah, so Bluetooth, RFDs, NFC, near field communication, that lovely tap and goes that we now use with our credit cards and that on FPOS. That's near field communication. That's where we basically have a circuit that we tap, which is energized and transfers the data. RFID is the closed tags and things like that. So it identifies the device as it comes in through a field. Bluetooth, as we spoke earlier, was the personal area network material. So your phone connecting to external speakers, your headphones, that sort of stuff. And is covered under 15.1 of the 802. 802, by the way, is Ethernet.
Can I just
so you know what it is.
ask, sorry, how is Alan connected to so many different Bluetooth devices?
Quite easily.
Really?
Yeah.
Because I swear I was capped at like 2 on my phone.
That would be a restriction of your operating system.
Okay.
The protocol actually doesn't have a restriction on how many it does, but it's not a small number.
Okay.
Yeah, the actual protocol itself, you can have 7 devices connected concurrently. So in other words, the device, according to the protocol standard, can have 7 conversations on the go at once.
Okay.
Okay. So,
well, it's a Samsung, so I don't know if that's the reason why, but I was certain it might be more. I guess I've never really tried it with more than two devices.
Um, the earlier devices and that were restricted. There has been revisions of the protocols over the years that have increased Bluetooth functionality, just like Wi-Fi standards have tweaked over the years. Okay. No, generally it'll be the operating system, not the carrier, because the carrier doesn't control Bluetooth. ZigBee and Z-Wave. This is basically the mesh services that come about via the Internet of Things. Okay, so these networks are wireless, meshed. In other words, they all sort of overlay each other and everything's connected to everything else. But speaking to guys that have actually worked with this stuff on a daily basis, because I've not actually worked with these two protocols, they don't have good things to say about it. Okay, so I'm not going to comment. Just be aware that they're there, and basically they've come around because of Internet of Things.
So that's
Okay.
kind of the system that allows you to control your house from your phone, so to speak.
They're basically a set of wireless access points all tied together.
Yep, okay.
But they came about from a proprietary perspective rather than a industry driven. It's basically, okay, we want this to, control all of the air conditioning points inside a building.
Yep.
Things like that. So
Okay.
how do we make it manageable for our client without having to spend big money on installing a business building management server and things like that? Oh, we'll just write an app for their phone.
Yeah. Yep.
Now,
100 kilobytes per second, that's kilobits per second. Wow, that's
yeah, it's
handy.
see, data speeds are huge. But when you're dealing with Internet of Things, they're basically just checking their status. Are you on?
Yep.
Do you have an issue? You know, they don't need big bandwidth. That's the thing with the Internet of Things that most people don't grasp is Internet of Things are generally lots of automated devices that are just checking in every few minutes or something. They might actually just power on like
So,
every 5 minutes and say, yeah, I'm still here, I'm still running, and shuts down again.
yeah. So 100 kilobytes per second, bits per second in that sense is fast.
Well, yeah, it's more than adequate for those brief conversations.
Yeah.
It's not like the main,
Because it's not like they're streaming videos to each other.
yeah,
Yeah.
it's not. It's basically just, handshake saying, yeah, I'm all good. This is my status. Okay, I'll shut up now for another 5 minutes. Bye.
Okay.
All right, so each standard of mobile technology has been called a new generation of telecommunications. So basically, it's as we have increased the functionality of mobile data, they've increased the capabilities of the back of house networks that connect all these mobile towers together. We get better RF communications to our mobile devices. Whether that's a good thing or not, time will tell. I'm not all that impressed with having to be on call 24/7. Basically, if an employer gives you a mobile, they think you're on call all the time. It's like, no, you pay me for X amount of hours. That's what you get me for. All right, server roles and client roles. So we're coming around full circle in how network architecture works, especially with cloud. So mainframes used to be the boss of the network, and the clients were just dumb clients. So they basically hardly used any resources on a client. They used to be known as a thin client because they didn't have any of the applications running locally. Everything ran off the mainframe. So as we move more and more to cloud-based services, we're going back to that old architecture of mainframes, which for us old guys were just sitting back having a good laugh about. So in a network, we have service providers and service users. So a user of a service is known as a client, and the provider of the service is known as the server. So you now have file, web, and email servers, so therefore you'll have clients using those services. DHCP is a dynamic host protocol. So basically, well, there's a typo, DCHP. DHCP, Dynamic Host Control Protocol, is where we basically have our clients send a request to the server to get configuration information for that host device. So standard information pushed out by the server is the individual's IP address, the subnet mask that applies to this network, and the gateway used by the devices to get off the network and to the outside world. Servers can also push out other optional information, but those three items are the core ones. The other one that is in there normally is the DNS server. So where you can find the server that translates names to IP addresses is normally within that information. And there it is. So basically the way DNS works is in the server, there's multiple of them around the world. They're all tied together. And they basically have a inverse tree. So basically they work from the back of the address. So your .com will be a branch. Within that branch, there will be Cisco under the listings of all the .coms. You'll find Cisco. Then under Cisco, there'll be FTP, WW, anything else, web servers, email servers, all those will be listed. And against the final entry, www, will be this address. That's how domain name lookup occurs. So basically, it takes from the right hand side and breaks up. So in Australia, the AU tells the domain name servers that you got to look in the Australian registry, .com, .biz, whatever it is, and that has a whole series of entries under each branch as you go down. Then on the final bit over here, it will tell it what the IP address is for that entire domain name. Print servers basically controls multiple printers if you wish it to. It basically provides a central point for all your hosts to contact for any print jobs that they require. So they send the job to the server and the server sends it out to the printer, rather than all the clients being connected to all the printers. They just connect to a print server. The print server controls all the jobs for the enterprise, so it doesn't overwhelm the client, the printers. So it batches the jobs, puts them in order of priority, and sends the jobs to the printers as the printers can handle the jobs. File server is basically just a collection of files on a computer. So what's the difference between a client and a server? The function. One is offering a service, the other one is requesting the service. Okay, so basically a server, when we look at hardware, a dedicated server will have higher spec components because it's trying to service multiple clients at once. But in the old days, a server and a client was defined as its function, not necessarily what it does. So again, a file server, I think it's in the name, it stores files. Other way, the other button. Yeah, there we go. Web server, it stores all these lovely codes that we're going to write. Studying, well, let me think. Tomorrow, we'll start looking at hypertext markup language tomorrow. So a web server holds the files that make up a site. So basically all the code that is in a document that tells the client how to represent that information and redisplay it on the screen.
I don't miss HTML. That's fun.
Mail servers have an interesting arrangement. So we have multiple protocols. The main one is SMTP, Simple Mail Transfer Protocol. So when you send a message off, you use SMTP, which until it gets to the final mail server, so the recipient's mail server, from the source to the recipient is SMTP. Then the recipient chooses what protocol to talk to their server with, IMAP or POP3. So POP was Post Office Protocol. Basically, you connected to the post office and retrieved your mail. So Post Office Protocol. Internet Message Access Protocol is a more advanced form, which allows you to do various options within it. So that one gives you more options, IMAP over POP. POP basically only allows you to retrieve your messages down. And once it's sucked it down, it's no longer on the server. Proxies act on behalf of the client, thus hiding the real connection. They can also be used to cache frequently accessed information. Are they still used in environments? Yes, they are. But there are other mechanisms that we can use to do the same thing now. Authentication, our AAA, so authentication, authorization, and accounting basically controls who has access to network services. Hi, I want a connection. Who are you? Give me your credentials. I'll check with a central point and see whether you're authorized to have access. I'll deny or permit you based on the reply from the AAA server. Syslog is basically a storage of all messages on statuses of devices within the network. So basically, everything that occurs within a network can be monitored. Whether you want to monitor every single thing, it's up to you. Accessing the network is via a network interface card. They come in all different shapes and sizes and connection methods. Plug-in cards for Ethernet, for token ring, for any type of connection, wireless included. And you can even get them via a USB connection. Okay, back in the day, we used to have a repeater. Repeaters basically extended the signal strength. So as you pushed a signal down the cable, it would get tired and weak. So you would put a repeater in to strengthen the signal and to send it on its way and increase the distance that you could send it. Hubs, depending on your definition, were either active or passive. Passive hubs just signal in, out, multiple ports, end of story. That type of hub was known as a passive hub, and every time you had a hub, the signal strength weakened. An active hub had a repeater function inbuilt into the hub, so it would take that original signal, divide it up, boost it, regenerate the signal, and then send it out to multiple ports. A bridge was a smart divider of a segment. So it would actually learn what devices were connected on each segment and limit the traffic based on that. So in this page here, if device A was sending traffic for the server here, the bridge would know that the server's on segment 1 and the traffic is destined for segment 1. So it would not send it to the devices in segment 2, thus reducing collisions and improving network performance. Now, a multiple port bridge is known as a switch. Okay, so switches learn every device that is connected to it, and they'll only send traffic for that device down that cable. Okay, just like the repeater learns what devices are on that cable, so does a switch. This benefit is there's less collisions occurring on that individual segment of cable, thus improving the throughput of the network. By less collisions, that means you have less retransmissions, which means more bandwidth overall, because more traffic is getting to its destination in a timely manner. Wireless access points are casting ourselves back into the dark ages of hubs, because we can only send or receive. Can't do both. And they all share the same device. So each of them are controlled from the access point, and only one of them can talk at a time. Okay? They can't receive and talk at the same time. They can only do one or the other. This is one of the reasons why our speeds on wireless networks are so much slower than wired networks, because we can't push the same amount of signal down radio rates, because we basically have one antenna that does both. It's listening or sending. Okay. Routers connect networks together, not devices, networks. Each physical connection to a router is a separate network. And you're going to go, oh, but I've got 4 devices connected to my router at home. No, you have 4 devices connected to the switch that is built into your router at home. Okay, so you have that WAN port that connects to your service provider, and then inside your router there's another port that connects to the switch. So there's actually 2 networks. There's the network that is your service provider, and the network that is inside your home, which has those 4 switch ports connected to. Just be aware that there's a difference. So routers connect networks, switches connect devices. What does a firewall do? A firewall applies policies to traffic. So basically access control lists, which are a set of rules that must be met, and they basically say, is this traffic allowed through? Yes or no. If it's allowed through, it goes through. If it's not, it's discarded. They're very simple little logics. They basically apply policy to the traffic. Can traffic from the internet come into my network as the source? No, denied. Can traffic from the internet come in as a reply to my clients? Yes. Firewalls are smart enough to know the difference of whether that traffic originated inside and is getting a reply from outside, or if it's outside just trying to get in. Next generation of protection was our intrusion detection systems, which basically were traffic monitors, and it's a bit like an antivirus for the network. It looks for patterns in traffic that it checks against a big database of patterns, and if it sees a match in traffic patterns, it'll send an alarm off to the management console saying, I think there's something dodgy going on here. I want you to check it out. It won't take any correction action against what it detects. Next generation came around as intrusion prevention systems, IPS. And this monitors the traffic, and when it detects something dodgy going on, it actually takes an action against that alarm. So it will stop the dodginess and send an alarm to the management console, but it will also automatically take action against what it has detected. Universal Threat Management is now a combined device, so all-in-one security appliance. So it will have firewalls, IPS, IDSs, proxies, email filters, VPN connection points. So it's a one-stop shop. And Cisco's product is known as a Adaptive Security Appliance, ASAs. They're quite nice little boxes. Endpoint Management Server is basically a monitoring service that has a nice little dashboard, as displayed in here, that monitors the health of your devices on your network. So it'll send out a probe to all these devices and ask about status. What's your CPU usage? What's your bandwidth usage? All these sorts of things, and collects all that information and displays it in a nice little user-friendly dashboard. Legacy or embedded systems are systems that are basically old, but you still use them. Embedded, we used to have things, one of the really good, this is going back quite a while. This was an example given to me many moons ago when I first got into this. So a embedded system was when the US was really ultra paranoid about security, and they would have a chip that would basically encrypt faxes between encryption faxes. So the embedded microchip would be in control of encrypting the file being transmitted, and basically it would negotiate with the other end. So if the other end was an encrypted recipient, it would encrypt the fax information between the two devices, so somebody can listen in to the transmission and print out the fax, for example.
It does seem
it's very easy to look at these old devices that run on very old systems as a security risk, because everything they do as far as security and all that has been broken, because they've been around long enough to pose that problem. On the flip side, you go through a period where they're a high risk item and then they revert back to a low risk item, and going, that doesn't make sense. Well, basically, a lot of security threats come from what is known as script kiddies. People that are basically just making viruses and other forms of attacks based on applications that generate. So basically, the application goes, okay, what type of attack do we want to generate? We want a bit of A, a bit of B, a bit of Z, a bit of H, bundled together, off it goes. Those scripts only target current things. They can't keep track of everything. So those scripts that generate new attacks don't generate things for old NT servers, for example, because nobody would be running NT servers in today's age. Well, guess what? Australia Post did up until very recently. They had a high attack level there for a while, and then it all stopped. because the scripts kept moving on with current technologies, and they stopped generating scripts to attack old technology. So, yeah, quite right, Robert. It happens a lot of times because a lot of businesses don't keep up with technology upgrades like we do at home. Home users tend to upgrade their technology much faster than businesses do, mainly because of the cost scale. Patch panels. Basically, in a business, you have lots of points that need network connectivity. So you bring all those various points back into a central location for distribution. So all those cables come back into a patch panel, and then we use a patch, which is a small length of cable, to patch from the panel across to active equipment located in a central space, normally known as a comms room. Okay, exactly, Robert. Yes, legacy systems. That's exactly my point. At one point, the vectors there, yeah, they peak, and then they become out of vogue, if you like, and become safe. Exactly. So people move on because they think everybody's updated the tech, whereas it's a lot more out there than people think. Power over Ethernet and Ethernet over power. Ooh, don't get these two mixed up. Okay, power over Ethernet is where we supply power to the device via the cable. For example, our wireless access point needs power supply for the transmitters. They generate basically 48 volts of power required. So we can put a power point next to them and a power pack for the access point, or we can use a power over Ethernet injector, which is either built into the switch or a separate power pack, and we can inject power into the cable. Now, in the old Cat5 days, we only used 2 of the pairs in the wire of 4 pairs. So 2 pair were not used, so it was very easy to send power down unused wires in the cable. But when the standard was increased from doing 100 megabits per second to a gigabit per second, we started using those other wires within the cable. So the power over Ethernet had to change. Instead of having a constant supply of power, we now send bursts of power down the cable, which is basically kept in a capacitor on the device for slow discharge. Now, power over Ethernet is very useful, especially with wireless. Now, Ethernet over power, yes, it is great. You basically, the only downside is you can't have it hanging off somewhere that has a surge protector. Alright, so basically the way Ethernet over power works is it uses your household power wiring as the transport medium for your Ethernet signal. So the way power works is it's a sine wave. Okay, we are injecting 240 volts at 60 hertz per second. All right, so 60 million 1,000 cycles a second. So it's a sine wave. So if it's a sine wave, we can add to that sine wave. By adding to the sine wave, we are transmitting. And at the other end, if we just apply a filter and take out our power sine wave, we're left with our Ethernet sine wave. And there we have transport. Cloud-based. Well, cloud-based. Oh, everybody's going cloud. It's so fantastic. Yeah. Yeah. I'm too old school. I don't like cloud. Why don't I like cloud? Because you do not have control over your resources. Yes, I do. I can access it here. Really. So who hosts you? Where are they located? Do they move your data around into countries that don't respect your privacy? You have no idea. Okay?
What if you make a cloud server in your house?
Of course you can have a cloud server in your house.
But then, then you've got, the safety of you've got control of your resources, and
Then,
I feel like that would be the best way to go.
Then that's not really a cloud, is it?
If you're not at home, it is.
That's just, we used to call that remote access.
Yeah, well, yeah. But I feel like because it's not really up in a cloud anywhere, so it seems kind of silly that that's what they've called it. But
no, it's got to be hosted on physical equipment somewhere in the world.
Yeah.
Okay?
Exactly.
It's a big sales comp. Basically, you're saying, we're selling you services, we'll look after everything for you, and it'll be on our equipment. We'll just charge you an easy, flat monthly subscription service, and there you go.
Yep.
Okay? So they basically have your file servers, your web servers, your
they have access
print
to everything,
servers, all running remotely as a service somewhere in a data center. So all your devices have to connect to this outside cloud, this service provider, and I'll just print to the cloud. Eventually, a printer has to be connected to the network and connected to that print server.
Yeah.
Okay, so all what they're doing is removing the cost, a massive upfront cost of setting up all your servers and that locally, to a flat, easily paid monthly fee, and their technicians look after it. So you don't need as many support staff, because we'll look after it as part of that monthly fee.
Yeah.
Oh, you just lost internet connection. Well, that's not our problem. Oh, look, you can't run a business anymore because everything's located off-site.
That's pretty sad.
Okay. So it has some massive downsides that people need to be aware of when making the decision to move. But basically, Beancount is just look, it's a flat, easily controlled and budgeted monthly fee, and we can save money by not having as many support people on site. We don't have to buy equipment, don't have to pay for upgrades. We just need to pay for the internet connection, which we pay for anyway. Oh, beautiful. They don't look at the security or implementations of loss of connectivity or anything like that. There are benefits. Major benefit of cloud is you can access it from anywhere in the world. So if you've got a mobile workforce, it's very, very nice. It makes sense to move to cloud-based. Okay, tools for making cables and maintaining your network. Wire cutters, wire strippers, crimping tools, punch down tools. Okay, so wire cutters to cut the cables that are damaged and things like that. Wire strippers to prep the cable wires to have plugs attached, and you need a crimping tool to squeeze the connectors together on a network cable to secure the connector to the cable. A punch down tool is used when connecting a cable to a socket on a patch panel or on the back of the wall. So to put it in very gross terms according to today's PC environment, a crimping tool makes a male connector. A punch down tool is used on a female connector. And if you think about that, you'll understand the differences. How do I check to make sure the connection I just made works properly? You can use a multimeter to check, because it's all a circuit multimeter. Use a tone generator, so you plug one end onto the cable and it makes a signal, and the detector picks up on that signal and makes an audible sound when it detects the signal. You can use a cable tester, which is generally how you would do it if you're doing patch leads and things like that, fixing your cables. A RF analyzer can be as simple as an application on a laptop and an RF aerial, or it can be a dedicated piece of kit, standalone kit that you walk around with. Loopback adapters were used to generate test signals on individual devices on a port-by-port basis. Still used today, but nowhere near as much as they used to be. Okay, cable types. Twisted pair cable. This is the most common in use, and it basically uses the twist in each pair of wires to protect each conversation from each other. So it reduces the signal jumping from each wire to wire by the rotation of the wires within the cable. Coax cable used to be widely used in TV aerials into the house, where most people would have known coax cable from that. Coax cable is used by cable TV providers along the streets, just a bigger, thicker cable. And we used to use it in the original Ethernet bus technology. So we used to have a coax cable running around the floor. We would cut it, insert a T-piece, and continue along our way and hang a host off a T. Thus the bus topology that you'll see in network diagrams later. Fiber optic cable is the last one in the list there. So these are a strand of either, well, glass is not really used anymore because it's too brittle. It uses light to bounce down a very small path within it. Now, normally it's 2 grades of plastic now that keep the light bouncing along the cable. So, coaxial cable, what's it made up of? Conductive core. Okay, normally copper, can be aluminium, but copper's better. It's covered in plastic so that it's insulated from everything. Shielding. This shielding is to protect it from external RF signals, and then the jacket is physical protection around the outside. Types of connectors, B and C is a bayonet, so you push on and twist just like the old light sockets, light globes. Bayonet, push in, twist. The F-type is your screw-on fitting, and N-type is there as well, smaller one. B and C connectors were the most common. Twisted pair cables. So this is the Ethernet cable that you're probably more aware with. The yellow 4-port switch sockets on most home devices, especially if they're coming out of Cisco. And you have two versions. You have a unshielded and shielded version. So the difference there basically is in the unshielded, all the wires are just in a outer jacket. With shielded cabling, you will have each pair wrapped in a shield, which is some form of foil, and then that is wrapped around with some braiding or foil shielding again, and then covered in the jacket. The shielded cable obviously provides more protection against external electromagnetic interference, but it's more expensive. It has more components, therefore more expensive. It's harder to terminate. Takes more time to make connections. More expensive. Okay, so we have different speed ratings depending on the type of cable we use. Cable classifications are known as category 5, 5E, 6, 7, 8, as we go up. So basically how it transmits via the wires within the cable and what sort of protection it gives depending on the twist rate, whether it's got shielding, or come down to our speeds, the distances. Okay. So when we're talking about twisted pair cable connectors, we basically have two types, 568A and B. If both ends of the cable is using the same connector type, so if they're both wired as an A, it's a patch lead. If they're both wired as Bs, it's a patch lead. If one's an A, one's a B, it's a crossover lead. And you go, why do we need two different types? Well, you have a transmit and receive pair of cables. So, pair 3 and pair 2. So if I'm transmitting on pair 3 and receiving on pair 2, at the other end, pair 2 is the send and the receive is pair 3. Okay, fiber optic cables. Not much more to go, guys. Only a couple more slides. Lot to take in, I know. You have a core. This is where your light is injected into, and on the outside of the core, you have some cladding, which, oh yes, you definitely will need to go over all this. And I will post the link to the recording as well. Okay, so the light band travels down the core and it reflects off the boundary of the core and the cladding. So it basically bounces back and forth in the core as it travels down the fiber. On the outside of the cladding, you have a buffer material which protects the core. Then you have another layer of material to protect that, and then the jacket. Now remember, each individual fiber is very tiny. We're talking microns of size. Okay, so 9 microns, 125 microns. It's tiny, 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 tiny. All right. So single mode fiber basically allows you to inject down basically a single path to get to the other end, benefit longer distance. Multi-mode fiber allows you to inject multiple sources of light, so it can use more bandwidth, but over a shorter distance. So you've got lower bandwidth, longer distance, higher bandwidth, shorter distance. And the various connectors. So you've got the ST connector, which is a bit like the BNC connector. You push in and twist to lock in place. The LC connector is like our cable, Ethernet cable. It has a locking tab. You push in, it goes click, locks in place. Then you have your multi-mode LC connector, which is both pair of fibers connected together in the same plug, and then SC connectors, which push in individually, just like an LC single connector does, but are square and don't have the same locking mechanism. And that is it. So, welcome to your very quick introduction into computer networks, a brief, very brief introduction into protocols and standards, why we use networking to connect devices, and what types of cables we connect. Now, this is going to give you a good building block for the CCNA course. We don't go through it as fast in the CCNA course. We actually spend time with, there's like a whole chapter on UDP and TCP. All right. So we actually spend time in exploring each element in depth under the CCNA course, which is the foundation of networking in that course. In this IT Essentials, we're just giving you the very broad strokes of understanding how things connect together. So there's a lot more material to go through in these ones. But as I said, this will give you a broad grounding for what we do on Thursdays moving forward. So don't worry too much if it doesn't all sink in this week. You will get it again in the other course unit, but in slower, more consumable chunks in the Thursday classes. Chapter 5 of the ITE course to read this week. There will be the usual chapter test there. You can, if you haven't already done so, complete the second assignment of the old unit, 4.2. Hang on, I need to bring up my other screen here. The 4.2.1 second assignment. That's just do a diagram and connect things together. The third assignment talks about the steps of installing an operating system into a device, so I won't assign that assignment until after we do installation of an operating system via a virtual machine in this topic. Okay. So I'll finish sharing the screen and I'll turn off that. So Tim